Imagine rewinding the universe to its very first moments, a time when everything we know was compressed into a space smaller than an atom, ready to explore the most dramatic event in cosmic history. Let's dive into the Big Bang. Picture this: absolute nothingness. Not just an empty room or the darkness of space, but a complete absence of everything. No time, no space, no matter, not even the laws of physics as we know them. It's mind-bending to think about, right? Scientists call this mysterious state the quantum vacuum. But don't let that fancy term fool you. It's basically the cosmic backstage before the universe's grand opening night. What's really fascinating is that this void wasn't actually empty. It was packed with pure potential energy, like a cosmic jack-in-the-box wound up tight and ready to spring. This is where our story begins, at a time that wasn't really time yet, in a place that wasn't really a place. Pretty wild, huh? Then it happened. Boom! In a fraction of a second, smaller than you can imagine, the universe burst into existence. We're talking about an explosion so powerful it created space itself. The temperature? A mind-boggling trillion degrees. During this first microsecond, the universe expanded faster than the speed of light in a process called cosmic inflation. Think of it like a cosmic growth spurt on steroids. As this expansion happened, the pure energy started cooling down just enough to form the first fundamental particles, the building blocks of everything we see today. It's like the universe was a superheated cosmic soup, gradually cooling down to form the ingredients of reality itself. And here's the kicker: all of this happened in less time than it takes you to blink. Now, let's talk about one of the most mind-blowing parts of the Big Bang: cosmic inflation. Imagine blowing up a balloon, but instead of taking seconds, it happens in a tiny fraction of a second, and the balloon expands from smaller than an atom to bigger than a galaxy. That's cosmic inflation, and it happened so fast it actually bent the rules of physics as we know them. During this growth spurt, the universe expanded faster than the speed of light, which sounds impossible, right? But here's the catch. While nothing can travel through space faster than light, space itself can expand as quickly as it wants. This rapid expansion smoothed out the universe like stretching a wrinkled bedsheet, creating the remarkably uniform cosmos we see today. Pretty clever of the universe, don't you think? Let's explore one of the hottest soups ever made, the quark soup. Right after cosmic inflation, the universe was like a cosmic pressure cooker, filled with incredibly hot particles called quarks and gluons, floating freely in a dense, super hot plasma. Picture a pot of soup where the ingredients are so hot they can't even stick together to form atoms. At temperatures millions of times hotter than the sun's core, these tiny particles were bouncing around like they were at the world's most energetic party. This phase only lasted for a millionth of a second, but it was crucial. It's where the basic building blocks of matter first appeared. Scientists at places like CERN have actually recreated tiny drops of this quark soup, giving us a window into those first moments of our universe. Let's explore one of the coolest moments in the universe's story, when the fundamental forces of nature came into being. Picture all the forces we know today: gravity, electromagnetism, and the strong and weak nuclear forces, starting out as one unified superforce. As the universe cooled down from its initial hot state, this unified force began to split apart, like siblings moving into their own rooms. First, gravity went solo, breaking away from the other forces. Then, the strong nuclear force branched off, followed by the weak nuclear force and electromagnetism going their separate ways. This cosmic divorce might seem like a downgrade, but it was actually essential. Without these distinct forces, we wouldn't have stars, planets, or even atoms. Now, let's talk about a pivotal moment that happened around 380,000 years after the Big Bang, the time when light finally broke free. Before this, the universe was like a cosmic fog, with photons, particles of light, constantly bumping into electrons and protons, unable to travel freely. But as the universe cooled to about 3,000 degrees Celsius, something amazing happened. Electrons and protons finally joined forces to create the first atoms, mostly hydrogen. This process, called recombination, cleared the cosmic fog and allowed light to travel freely through space for the first time. Think of it like the universe finally turning on its headlights. This first light is still visible today as the cosmic microwave background radiation. It's basically the universe's baby picture, and it tells us crucial information about our cosmic origins. Let's explore how the universe cooked up its first elements. It's like following the ultimate cosmic recipe. As the universe continued cooling, something remarkable started happening. About 3 minutes after the Big Bang, protons and neutrons began sticking together in a process called nucleosynthesis. Think of it as atomic Lego blocks snapping into place. First came hydrogen, the simplest element, followed by helium, and even a tiny sprinkle of lithium. Here's the fascinating part. This cosmic cooking show only lasted about 17 minutes, but it created nearly all the hydrogen and helium we see in the universe today. In fact, when you look up at the stars, you're seeing the results of this brief but crucial period. The heavier elements would have to wait for stars to form. They're like the universe's pressure cookers, creating everything from carbon to iron. Let's explore one of the most remarkable pieces of evidence we have for the Big Bang, the cosmic background radiation. Think of it as the universe's oldest selfie. This ancient light has been traveling through space for about 13.8 billion years, and it's basically a snapshot of the universe when it was just 380,000 years old. When we look at this radiation with special telescopes, it shows us a pattern of slightly warmer and cooler spots, like a cosmic temperature map. These tiny temperature differences might seem insignificant, but they're actually the seeds that grew into everything we see today. Galaxies, stars, and even the planet we're standing on. It's mind-blowing to think that every time we detect this radiation, we're literally looking at the afterglow of the Big Bang itself. Let's dive into one of the most dramatic cool-downs in history. Imagine the universe starting at a mind-boggling temperature of about 10,000 trillion degrees. That's way hotter than anything we can create on Earth. As space expanded, this cosmic furnace began to cool, kind of like how a hot cup of coffee cools as it spreads out in a bigger mug. Within just the first second, temperatures dropped to about 1 billion degrees. But here's the cool part. This wasn't just a simple cooling process. Each temperature milestone triggered major cosmic events. At trillion degrees, quarks could finally form protons and neutrons. By billions of degrees, atomic nuclei could take shape. It's like the universe was following a precise recipe, with each temperature drop unlocking new possibilities for matter to form. Let's connect the dots between those first explosive moments and our universe today. The Big Bang wasn't just ancient history. It's like the universe's DNA, still influencing everything we see. Those initial conditions set up the perfect balance of forces that allow galaxies to spin, stars to shine, and planets to orbit. The hydrogen created in those first minutes, it's still the most common element in the universe, fueling stars like our sun. Even the way galaxies are spread out across space follows patterns set up during cosmic inflation. When you look up at the night sky, you're seeing the amazing results of choices the universe made in its first few minutes. It's mind-blowing to think that everything from the air we breathe to the ground beneath our feet can trace its story back to that singular moment of creation. Thanks for joining me on this cosmic journey through time. The Big Bang's legacy continues to shape our universe in fascinating ways. If you enjoyed this mind-bending exploration, hit that like button, subscribe for more space adventures, and share with fellow cosmic enthusiasts.